Hello everyone. If you haven't watched the linear regression video, please do that first. Quadratic regression video or quadratic regression topics are very similar to the linear regression topic, and we will be using pretty much the same process. Today I will go over the calculator steps with you, and we will be able to find the quadratic regression equation, and then we will also be able to find a maximum and a minimum of a quadratic equation from that regression equation. Here's our first group of data. When we have the data, we're going to enter the data on the list. And I'll pull up my calculator, and we will go to Stat, and we will hit Edit. It will bring us L1 and L2. For each one, we're going to fill in the L1 values, and 1, 2, 3, 4, 5, and 6. These are my X values. For Y values, we will fill in 18, enter, 12, enter, 9, 7, 8, 10. As you can see, as the X values are increasing 1 through 6, values are decreasing and then increasing, which is an indication of a parabola. That's why we know that we are dealing with a quadratic regression. As the next step, after entering the data on our calculators, we are going to find the regression equation. To do the regression equation, we are going to leave the data screen. We will do second quit. On the clean screen, we will hit Stat, and instead of Edit, because we have already edited the lists, we are going to move forward to Calculate section. On the Calculate section, we are going to select number 5, the fifth one, Quadratic Regression, and we will hit Enter again. It will ask, do you want X to be X values from list 1, Y values from list 2, and we're going to say yes and enter for both those. Frequency and other ones we are not worried about right now, and we will hit calculate, and it will bring us a quadratic equation where we have ax squared plus bx plus c style. In this style, we have a value as 1, b value and negative 8.54, we can round to nearest hundredth. Now we have our a values, b values, and c values. We can write our equation as y is equal to x squared, that's 1x squared, minus 8.5428574143x plus 25.4. As the next step, we are going to graph this, and we can actually put the equation in the graph section, and we can round to nearest 1000 or even 100 would be okay. And we will put the equation in the graph, and we can graph it. After writing the equation on the y is equal to section, we can hit the graph button. It will graph our equation, and since we can see that this equation is on quadrant 1, we can even change the zoom and see it closer. Zoom button is in the middle here, and we can select zoom quadrant 1, and it will show our graph in the quadrant 1. You can play with the zoom button to get the closest view of your parabola as well. If I click on zoom again, and instead of selecting quadrant 1 and or any other ones, I can try to select zoom fit, and it will fit the graph on my screen. If I want to go back, I will select zoom standard. So zoom fit, it gives us the graph that's fitted to the screen. If I click on zoom standard, that's number 6, it will give me the standard way, so that's how you can go back. Here is one for you to try. Go back and follow our steps. You would have to go to stat and edit, and you should clear your existing table and put new values. It says for 1985 put 0. If you start typing 0 where the 1 was, it will just replace the values. For the extra ones, you can actually delete them as well. And we only have 5 year worth of data in here. I'll erase the last one. Just make sure that if you have 5 x values, you must have 5 y values as well. You can either hit delete button for each of them, or whenever you're on the top, you can hit clear button once and then bring it back down. It will clear the entire row. Now go ahead and put your y values and then create your quadratic regression equation, and we can calculate the uh, value for 2010. Calculating value for 2010 will require that you write your quadratic equation y is equal to, instead of 2010 would be, as far as the year, we will start with 2010. From 1985 to 2010, t will be equal to 15 years. So y15 is what we are looking for. So we would have a value and x squared. For x squared, we will put 15 squared, and b value, and then x, and then the c value. So that's how your equation should look like. We can go over this in the class as well. We're going to briefly go over max and min again, and we have looked into maximum and minimums earlier, and we know that the equation for finding the x-coordinate of a maximum is negative b over 2a, and yeah, after find negative b over 2a, then we can find the y value by substituting negative b over 2a into the original function. Now, our y value will be found by substituting the x value into the original equation. Once we find the x and y value together, that would be our vertex where the minimum and maximum values occur. Let's look at each of these equations and find the maximum value of each quadratic equation. I will start with A, and you can do B on your own. My A value is equal to 1, B is equal to 4, C is equal to 0, X max or X min, in this case we have a min value, so I should write min. X min negative b over 2a, negative 4 over 2 times a is 1, which is equal to negative 2. So I can also confirm from the graph that this is negative 1, this is negative 2. Yes, x coordinate is negative 2. To find the y coordinate, I will do y min is equal to, I will just substitute the x value back in the equation, negative 2 squared plus 4 times negative 2. Negative 2 squared is positive 4, and minus 8, that's equal to negative 4. And if you look at the scaling on our graph, it's +2, +4, -2, -4, -6, and the coordinates for the vertex is actually -2 and -4. So we can find the vertex point with x value and y value together. Now, try the next one on your own and confirm your answer with the graph as well. Last thing we're going to look into is how to find the maximum and minimum on the calculator, the vertex. We have an example function in here. Our example function is -2x squared minus 6x plus 7. First, we're going to enter the equation into y is equal to section and clear whatever equation is there. And we're going to put -2x squared, then minus 6x, and plus 7. Next, we're going to, it says adjust the weaving window so it's visible. Our windows should be okay, but we can still click on the window button and confirm that our window is wide enough to show everything. And on our example, we have x min as -6. It can be more than the minimum, and x max is 10. I will just put the 6 in here just so that we can see the same steps from the example as well. And I'll adjust y min as -20 and y max as +20. And y scale is 2. We can adjust these or play with these as we go, and you can reset your Windows specs later on too. Now, for the third step, next step, since we adjusted our window, now we're actually going to find our maximum. You really don't need to adjust the window to find the maximum. To find maximum, we're going to hit second button and then find calculate. Second, calculate is under trace, so if I put second calculate, it will bring me the screen of calculating things. I could calculate zeros, minimum, maximum, intersect, and so forth. Because this is an equation where the leading coefficient is negative, it will be a parabola looking down. So I know I need to find a parabola looking down, so a parabola looking down will have a maximum point. So I will have to choose maximum from the calculator. Once I select maximum, it kind of draws our graph already. Now on the graph, we're going to follow the directions of the calculator. It says find the left bound of your graph, of your maximum point. And if you can see, my cursor is blinking, and we're going to move that cursor on the to the left side of the maximum. I will move it until I get to the left side of the maximum. I think maximum is going to be somewhere up here, but I don't know exactly. So I will go left side of maximum. It doesn't matter exactly where you go as long as you're on the left of maximum. Go ahead and hit enter. And then it will ask you to find the right side. I will move my cursor and find the right side of the maximum. Hit enter again. This time it says, guess where do you think the maximum is going to be? I will go towards the middle of it where I think the maximum should be, and I hit enter again. And the calculator gives us the maximum as -1.4999 and y is equal to 11.5. I think it's fair to estimate at this case to -1.5 and y is equal to 11.5 as our points. That's pretty much it. And as I said earlier, please watch the linear regression video first and then watch this video to make sure that you understand the calculator steps. In the class, we will have plenty of time to go over these calculator steps and processes.